Hello guys, welcome to this new tutorial. We're gonna learn how to use machine learning to determine the locations of trees in a Heighfield. How this is gonna work is we're gonna get real life forest data from a forest in Colorado, and based in some of the values of the tree, such as which is the conditions that this tree grows on. This could be the aspect, like the degrees that the tree has in respect to the sun, or like the slope of the terrain where the tree grows, the elevation, the type of soil. All this data can be retrieved in public data sets. We're gonna use this information to determine back in Houdini site which is the tree that has more probability to appear in a certain location. I'm gonna show you the data set that we're gonna be using. This is a competition of Kaggle that they share a data set that corresponds to the Roosevelt National Forest of northern Colorado. And this data set has different parameters, including the elevation, the aspect of that point in where the trees are growing, the slope. It has also information regarding the soil, the closeness of these trees to any close water, and it has also information regarding fire points, as well as the presence of wilderness. One thing that should be important to know is that this data set is using 7 types of trees, which means that in Houdini site we're gonna be instantiating in our environment 7 types of assets. If you are planning to instantiate more, you should probably use a data set that contains more elements, or make some data preparation to support have this data set or similar data sets more values. So the first part that we're gonna do is learn how the training of the model is done. For this kind of project, we want to classify trees based in some conditions, and there's different ways that you can build this model. In this case, I've decided to use a random forest classifier, but you could have used any other method that allows you to perform classification. The first thing that I've done is to load and process the data that we retrieve from the dataset. So in the dataset, as we saw, we have a lot of different columns, like the elevation, aspect, slope, origin distance to water. There is also different types of soils. All this information about the soil types, we don't really use it, since we don't have a way in Houdini to make those soil variations. So in the load and process data step, what I'm gonna do is I'm gonna say that for the training side, I'm only going to use the elevation, the slope, the original distance to water, and the vertical distance to water. And for the y, so the value that we try to calculate, which is the tree type, this is called the cover type. So our y is only going to contain that value. I'm also performing a mixed mask scalar. This is not really necessary for random forest classifiers to have the data normalize or scale, but I decided to do it just in case there may be some small improvements, considering that the data from Houdini may not have the same elevation and slope scaling. I was here also adding features together. This sometimes improves the model performance. At the end, I found that it's not really affecting at all, so I comment that part of the code. And the next step is going to be the training of the model. As I said, I'm using a random forest classifier, so I'm just sending the training data, the resulting value that the training data should have, and then I'm evaluating the accuracy. I'm getting an accuracy of 0.68. This is quite low, but considering that we are just using a bunch of parameters, we are skipping a lot of the parameters that we get. It's okay. It's an acceptable value. And later, what I'm doing is I'm saving this into a file using a joblib dump method, so that I can load it from Houdini side. Now I'm gonna show you the Houdini side of the project. What I've done is I've created a Heighfield. I've applied some of the Heighfield noise and Heighfield distort to make the Heighfield have some some terrain looking, and then we're using a Heighfield erode to add a bunch of useful attributes for us, including what it's doing, it's creating a bunch of volumes, including water and the height of the terrain. What I wanted also is to have a slope. I couldn't find a way to do it in Houdini directly, so I created a new layer that is a copy of the height that's called slope. So after this, you will see that we have also a slope volume, and I'm using here a Heighfield wrangle that what it's gonna do is create me fill me the volume, the slope value of the volume with the slope at that specific point. Then I'm gonna scatter a bunch of points. So after this, you see that I move from 7 points, which are the 7 volumes, to 1,975. Then I'm deleting those volumes that I don't need, so that I only have the points. And here I added a switch to, let me see what I have here in the wrangle. Oh, so here I created I initialized the cover type attribute, which is the attribute that determines which tree to use, to 0. This is necessary because when I'm in my machine learning model, I'm specifying that I want to have each point a specific value for this cover type, and for that I'm using this method, point set attribute value, and this method raises an exception in the case that the attribute doesn't exist beforehand. So the easiest for me is to just create it with vex, and then this method is not gonna raise any exception. So let's take a look at what this machine learning model cover type does. I'm here creating all the columns that the columns that I'm using from the dataset, which is the elevation, the slope, and the presence of water. I'm creating a Panda data frame with these values, and then for each point, I'm gonna extract the height, the slope, and the water. These are point attributes that they are corresponding to the volume values that were at this point position. So when you are converting the Heighfield to a point using the Heighfield scatter, you see that some of the volumes, like the height, it's converted as a point attribute. So this is this point here, it's gonna have the value of the volume at that specific point, and this one is gonna have the value of the volume at that specific point. So that way I can get the value at that location. And after this loop, the X is gonna contain a data frame of all the points. So each row is gonna correspond to a point. The first row is gonna be 0.0, 0.1, and each point is gonna have all those values. And then I'm applying the same min-max scalar which is gonna move all my values to between 0 and 1. I need to do that because I'm doing the same thing for the training, so I don't want to have to have different results in Houdini side when I'm evaluating the model than when I train it. So any kind of scaling that you do to the training set, you need to do it also for the in here at this point. So now I'm loading the model that I previously saved, and I'm predicting the new y, which the y corresponds to the value that the cover type should have. And after this step, you can see that we get in each point the cover type, which is the type of tree that is best for that location. And later on, the only thing I'm doing is I'm using a copy to points to copy some spheres, and you can see that I specify that the change of which sphere to load is based in the copy type. So here I have 7 spheres, each one have a different value for the copy type, and a different color as well, which let us see that looks like, because these points are very high and they have a certain kind of slope, and they are also very far away from the water, there's this type of trees that has more chances to grow, while in these parts that are more closer to water, they have a lower slope. This orange type of tree seems to be the one that matches more this environment. Then there is those like kind of like bluish, whitey bluish trees that seems to grow very well in water. The orange ones, they need to grow in flat terrains close to water, but not in very close to water. That's why they don't appear in this area. So that's it. Like here I also make some changes to show trees instead of spheres, but you can show any kind of object, any kind of 3D asset that you may have in your data, in your show or your project, and it can be a way for any environment artist to get more real results from what they are scattering. In contrast, I created this attribute wrangle that what it's doing is for each point setting a random value to the cover type, and you can see the difference. Like if I use a random value, it's a mix of trees, completely aleatory. There's randomness for the decision, so no logics to determine where might be the best place. But right now we can see that the machine learning model is being applied and it's learning. Thank you very much for watching this video. If you like, feel free to subscribe to my newsletter, and have a good day.